All right, A17, let's get some homework done. Piecewise define functions. So first off, let's look at the actual function itself, right? F of x is equal to negative 3x minus 4 if x is less than negative 1. And f of x is equal to x if x is greater than or equal to negative 1. So we have two separate lines here, right? We have the top line when x is less than negative 1, so left of negative 1, and then f of x is equal to x right of negative 1, right? Greater than or equal to negative 1, that's to the right. So we know, just in general, that at negative 1, x equals negative 1, something's going to happen, right? Something visually is happening at negative 1. So just in the back of our minds, right, you don't necessarily need to graph this, but it is nice to know that at x equals negative 1, right, this line here, something's happening, right? Something's happening. That's where the line gets cut off for both graphs. So let's see. I know that for the top one, the y-intercept is negative 4. So at x equals negative 4, at y equals at y equals negative 4, it crosses the y-axis. Yeah, and the slope is negative 3. So down 3 to the right 1, down 3 and to the right 1. So this is going to be down 3 and to the right 1 in both directions. Okay, so here's the deal. Here's the line, negative 3x minus 4, right? But we don't want the entire line. In fact, we only care about when x is less than negative 1. So anything left of negative 1 is what we want. Anything greater than negative 1, we don't care about this line, this part of the line. So I don't care about this part. And because it's strictly less than, it's going to be an open circle on this green line, right? So we can technically do away with the green line. I just had that there as a visual of just so you could kind of see where x equals negative 1 is. So right at x equals negative 1, there's our line. Oh, you can't see it. Okay. So this is the top part. This is the first piece, right, of the piecewise function. Okay. At y equals x, f of x equals x. That's the 45-degree line through the origin, right? It looks like this. But again, we don't want the entire line. I don't want y is equal to x, right? We only care about a piece of it. And the piece that we care about is x is greater than or equal to negative 1. So to the right of negative 1. So notice to the right of negative 1. And this is a closed circle because it's greater than or equal. It's closed. So closed circle. And everything to the left, we don't care about. So here's my piecewise function. This is it. All right, so looking at the domain of this, right, domain is going to be all the x values. So if you imagine a slider that you can slide left and right, the most left, well, it's coming from negative infinity, right? Because of the arrow implies negative infinity. So it's going to go from negative infinity up to So right around x equals -1, right? People tend to get nervous. But when you have a closed circle and an open circle on top of one another, you can basically consider this to be continuous in terms of x, right? Because where the red leaves off, the blue picks up like right away, right? Because one's closed and one's open. So, and then it continues towards positive infinity, right? Because that's what the arrow on the blue side represents. So this is basically negative infinity to infinity. This is interval notation, right? This is interval notation. And for inequality, we can call it all row numbers. And then for set notation, curly bracket, we're talking about x's, right? X is a real number. And we're referring to all real numbers. Okay, the range is going to be the y's, right? Again, imagine a slider going from bottom to top. And we're coming from negative infinity. But notice here at, say, -7, the graph, oh, you can't see it. The graph doesn't exist, right? The graph doesn't exist until y equals -1. At y equals -1, that's the first occurrence of the graph. So we're going to start at -1. In fact, it's a bracket because we're including -1 into this. And as you slide up the y-axis, as you increase up the y-axis, the graph is defined everywhere, right? Everywhere, any y value above -1, the graph is guaranteed to exist, right? All the way to infinity. So this is going to be up to infinity. Parentheses. Infinity always gets the parentheses. For inequality, we want, again, we're talking about y's, and it has to be greater than or equal to -1. For set notation, curly bracket, we're referring to the y's. We know that y is a real number, and y has to be greater than or equal to -1. Curly bracket. This is greater than or equal. Okay, number 2. Explain why the graph shown below does not represent a function. Okay, right here, this is the main reason, is that for a function to be a function, the x's can't repeat. You can only have one x value to specifically one y value, right? One distinct x value to one y value. So if you have multiple x's, not a function. Matter of fact, if you have more than one x, then more of the same x, then it's not a function, right? And this fails the vertical line test. Vertical line test. Right, x's repeat. All right, number 3. So a welder earns $20 per hour for the first 40 hours she works in a week, and $30 per hour for each hour over 40 hours. Use this information for questions 3 to 5. All right, so we want to write a piecewise function that can be used to determine the welder's earnings when she works X hours in a week. All right, so X hours in a week. All right, so X is going to equal hours, and then we'll let Y equal the amount of money she makes. So let's first define our function. All right, so f of X is going to be equal to, there's 2 parts. So she earns $20 an hour. So if X is hours, so 20 times X, right? This is going to be the equation for the first 40 hours. So from 0 up to 40, including 40, right? So this is if X is less than or equal to 40. All right, for everything over 40 hours, she's making $30 an hour. So 30x if X is over 40, so greater than 40 hours. Okay. So at 40 is where things start to happen, right? At X equals 40. Let's see if we can graph this now. So we have the X-axis and the Y-axis. All right, let's let the X-axis be the hours she works. So this is going to be hours. And then the Y-axis is the money. Okay, we know that she needs to work more than 40, so there needs to be at least 40. So let's go by tens on the X-axis. Right, every other one will be a 10. So 10. I guess we're going by fives, really. It's 5, 10, 15, 20. Okay. And then for the money, Y-axis go by 200. So every tick is a 200. All right, we'll go up to 3,000. That should be sufficient. All right, so let's look at this. See if we can wrap our heads around what's happening. This is going to be the top one will be in red. All right, if you work 0 hours, you make 0 money. Right, when X is 0, you get 0. Because 0 times 20. So at 5 hours, 5 times 20 is 100. Okay, so that's not necessarily, it's technically it'd be right here. So at 10 times 20, 200. And we kind of see a pattern happening, right? We're getting, so at 20 hours, 20 times 20 is 400. So 400. All right, and then we sort of get this pattern that's happening right here. We can start inductively reasoning this thing here. So this is going to be 40, up to 40 hours, right? Up to 40, this is what she'll make, $800. And this line represents her time up to 40 hours, including 40. All right, once she hits 40 and she keeps working, then 40 times 30, 4 times 3 is 12 with 2 zeros. So at 40 hours, she'll jump up to 1,200. Now she won't make 1,200 at 40, right? Because 40 is included in the top line, but the blue line will definitely pick up. So this is going to be, so let's say at 50 hours would be 1,500. So at 50, she's making 15. $15 would be about there. So we can already see we're going up 1.5 and over 2. So right, and then at 80 hours, she'll make 2,400. Oh, really can't see that. At 80 hours, she'll make 2,400. So connect these dots. You don't typically work past 80 hours. So, I mean, she could, in theory. Right, so here, this is the graph that represents this particular worker's wages in a week that she could potentially earn. All right. There it is. So let's look at number 4. We're going to use this. 4 and 5 is going to use this chart. So why they would put it on the back, I don't know. Oh, well, this was 4. 4 was graphing the piecewise function. Too easy. 3 was defining the function. 4 was graphing it. Cool. So let's see. 5. How much does the welder earn if she works 48 hours. Okay, so we'll go to 48 hours. So it's right below 50. So right here. To get a precise number, 48, we're going to use the bottom one. So 48 times 30. All right, we're going to use the bottom one. So this is going to be 3 times 8, 24, 12, 13, 14, add a 0. 1440. All right, number 6. The domain of a function is all real numbers greater than -2 and less than or equal to 8. So we want greater than -2 and less than or equal to 8. So here is the domain for some function. Write the domain using an inequality, interval notation, and set notation. Okay, well, I already did that, right? Because it's greater than -2 and less than or equal to 8. Okay, so there's the inequality. Greater than -2 and less than or equal to 8. The interval for this, right, so hold on. So let's think about this, right? Because I went straight to the answer. Most people won't go straight to the answer. So if you're reading this for the first time and you say, okay, x is greater than -2, then you're probably going to do this. X is greater than -2. And then you're going to say, okay, and less, so that's greater than -2, and we want less than or equal to 8. So x is less than or equal to 8. So we have two inequalities. This is where you have to have some sort of number sense, right? Because you always got to think about a line, a number line. Typically, when you're doing these, there's only two particular scenarios, and I'll show you both. You're either going to have it where the graphs are opposite of each other, or where the graphs go towards each other. Right? These are typically the only two scenarios. Here, if you were unsure on which way, then that's fine. Then all you got to do is just graph it, right? If you graph it, I feel like it becomes clear. So you take your number line, and then you tick out the 2. Okay, so I have -2 is to the left, 8 is to the right. Right? It doesn't make sense to put 8 on the left because 8 is bigger than -2. Bigger, big numbers go to the right. So this is going to be an open circle at -2, and we want greater than. So this is definitely going to be to the right. Then we say, okay, x is less than or equal to 8. So this is going to be a closed circle because it's or equals, and we want less than, so it's going to go to the left. So these are going to meet in the middle. That's typically how that's going to go. So once you have this, right, it's not two pieces. So I don't want two separate inequalities, right? It's one piece. So I want one inequality. And this is going to be x is in between, right, -2 and 8, except it's or equals for the 8. So that would be the inequality. The interval notation is just as easy. You just take the two numbers, parentheses because it's strictly less than, or the open circle, and then bracket because of the closed circle, or equals to, right? Less than or equals. Set notation is even easier, right? Because you take the curly bracket, you say x such that x is a real number, and then you use the inequality. -2 to 8. All right, number 7. the range of a function is -4 to infinity, including -4. Write the range using inequality and set notation. Okay, so inequality is going to look like this, right? It's going to deal with the y's. So we want from -4 all the way to infinity, all the numbers. So y has to be greater than or equal, because it's bracket -4, right? Y is greater than -4. For the set notation, talking about y's, y has to be a real number, and y is greater than or equal to -4. Okay, we're evaluating a piecewise function. So we're doing 3 different values. So first, when x is less than 4. So when x is less than 4, which one of these conditions does it fit in? Right? This is going to be x. So we're going to use the top one when x is less than -3. So -4 is definitely less than -3, right? Because if you think about a number line, again, if this is -3, -4 is going to be to the left, which implies less than. So we're using the top one and top one only. Now note, you could plug -4 into any one of these and you're going to get a number, but you're going to get an incorrect number. Only one works. So we're going to use the top function. So for x is equal to -4, we're using the top. So -5 times -4, we get +20. So when x is -4, y is 20. For x is equal to 1, where does 1 fit in? 1 is definitely in between -3 and 4. So we can use the middle one. So when x is equal to 1, we're going to use the middle function, x squared. So when we plug in 1, we get 1 squared. And we get 1. So when x is 1, y is 1. It's kind of interesting. And then lastly, x is equal to +4. So we're going to use the bottom one, right? Because here it says when x is greater than or equal to 4, use the bottom one. So when x is equal to 4, we're using the bottom function, or the bottom piece of the function. So 2x plus 4. 2 times 4 plus 4. So 8. 8 plus 4 is 12. All right, so that's pretty straightforward. You just identify where does x fit in, and you use that particular equation. Okay, write the equation of the piecewise function shown below. Okay, we have 2 pieces, so let's define this. So f of x is equal to, we have 2. So let's do, there's different ways of doing this, right? There's different ways of doing this. Let's just identify this line, right? So the line, the y-intercept is 0, right? Because so y equals mx plus b. That's what we're using. Well, the b value is going to be 0 because it crosses at 0. And the slope is going down and to the right, so it's going to be negative. So the slope is down 2 over 1. So down 2 over 1. So down 2 over 1, which is basically -2. So -2x plus 0, right? So I don't care about the plus 0. And right? Negative 2x represents the whole red line that I drew. But we don't have a whole red line. We just have a piece. And in fact, it stops at x equals 1, right? At x equals 1, and everything to the left of 1. So x less than 1. And it's less than because it's an open circle, right? It's an open circle. The next line, the next piece. So if you extend it out, right, we see that it crosses the y-axis at negative 2. And then the slope is up 1 over 1, up 1 over 1. So 1x minus 2. Again, we just want a piece, right? We don't want the whole line. So we want when x is greater than or equal to 1. Typically, when the open circle and the closed circle line up on the x-axis, that's where the numbers match, right? If they weren't lined up and they were offset, well, then there would be different x values. But when they line up, they have the same x value. So here's the function for that, or here's the equation for this function. Is that it? All right, that's what I'm talking about. Okay, only 9. All right, bet. So hopefully this helps someone out. Catch you guys in the next video.